Hi guys, this is Miss Goal. Today's lesson is Module 1, Lesson 1, Exponential Notation. Your outcomes for today's lesson are students know what it means for a number to be raised to a power and how to represent the repeated multiplication symbolically. Students know the reason for some bases requiring parentheses. The first thing I'd like you to do is actually to pause the video, and I'd like you to try completing the opening exercise on your own. And when you're ready to continue, just unpause the video. Okay, so what you were asked to do was, without actually solving this, what is another way to rewrite 3 plus 3 plus 3 plus 3 plus 3? And you actually learned this back in elementary school. You learned that we could rewrite this as 3 being multiplied 5 times. For the next part, it says, what if we change it to multiplication? How could we rewrite that? And this is something that you may not have gotten because it is fairly new to us. When it changes to multiplication, we're going to basically change it from multiplication to powers would be the next step up. So this would be a base of 3 raised to the 5th power. And that's really what we're going to take a look at in this lesson, is how can we use powers and write things more effectively when we're doing repeated multiplication. So just like our previous example, you can see here that 5 to the 6 means 5 times 5 times 5 times 5 times 5 times 5. You can see why we write it as 5 to the 6 and not as the repeated multiplication, because it's pretty redundant to say. Similarly, if you see, we have the fraction 9/7 and it's raised to the 4th power. So this means you have 9/7 multiplied out 4 times. And just to generalize this, if we make this any base x and any power n, x to the nth power would mean x times x times x and so on, an n number of times. So this is called x raised to the nth power. So n is the exponent of x, and x is the base of x to the n. So let's take a look at a couple of examples. You'll notice example 1 and example 2 are the same exact problems that we had above here. So we already know that 5 being multiplied out 6 times is 5 to the 6th power. Likewise, 9/7 being multiplied out 4 times together is 9/7 raised to the 4th power. And I want to pause for a second and notice I write it without parentheses, and what I want you to see here is that when we write it like this, it really only looks like 9 is being raised to the 4th power. That is why parentheses are so essential here. We have to put them around the entire base to identify that it is the entire fraction that is being raised to a 4th power. Otherwise, people might misconstrue that and think that it's only the 9 being raised to the 4th power. And you may see that at times, so you need to know the difference of when there is and is not parentheses. So using that knowledge, we're going to go to example 3 and expand out our base. Now we have -4/11 raised to the 3rd power, and I want you to notice that the negative and the 4/11 are both inside the parentheses, meaning that is what is going to be repeatedly multiplied together. So here, when I expand this out, I'm going to write -4/11 times -4/11 times -4/11. And you'll see something similar in example 2. Here we don't have a fraction, but we have a negative. So here we have -2 raised to the 6th power, and I know that my base is -2, again, because it's inside parentheses. So when I expand this out, I want to multiply out -2's 6 times. So -2 times -2 times -2 times -2 times -2 times -2. 1, 2, 3, 4, 5, 6. Now, I want to show you how this is different from 2 to the 6th power, which is then negated. That would be without parentheses. So if I had 2 to the 6th power negated. The difference here is that basically the base here is positive. It's a +2 raised to a 6th power, and then that result is negated. So if I were to expand this out, the negative would stay out in front, and I would just have +2's being multiplied out 6 times. And I want you to notice here, we don't have to find the final answer, but if you think about it, if I multiplied these two negatives together, I'd get a positive, and the same thing would happen here and happen here. So when I multiply this top one all together, I'm going to get a positive answer. But when I look here, I multiply all these twos together and I get a positive answer, but then this negative negates that whole thing. So it turns the final answer into a negative answer. So you can see that these two are completely different. So you have to know when you have a negative base and when you don't. If you have a negative base, there should be parentheses. Let's just take a look at example 5, just an example using decimals. And it works the same way. We have 3.8 raised to the 4th power. So what you're multiplying out repeatedly is 3.8. So 3.8 times 3.8 times 3.8 times 3.8. Now, let's just take a look at general cases here. And I do have actual numerical bases, but we're just saying any number of exponents. So I'm going to represent that using the letter n. So suppose n is a fixed positive integer, then 3 to the nth power is going to be defined by 3's being multiplied out n number of times. And you can see in all the examples below here that works the same way. So whatever the base is, that's what's being repeatedly multiplied. Wanted to mention this because a lot of people make a mistake of looking at a problem with exponents and thinking, oh, I just have to multiply the base and the exponent together and I get my answer. For example, 2 to the 3rd power. I have a lot of people give the answer, 2 times 3 is 6. Well, that is not correct. What you're actually doing here, if you expand this out, 2 to the 3rd is equal to 2 times 2 times 2. We know 2 times 2 is 4. 4 times 2 is actually 8. So you need to make sure that you fix that misconception right away. You are not just multiplying the base and the exponent. Okay, finally, let's just take a look at what we have learned today. We talked about how you would say x to the nth power when you see any base raised to any power. You know that the n within that is the exponent and the x within that represents the base, and that is what is repeatedly being multiplied. When we have x to the 2nd power, we actually more commonly call it x squared. Same thing goes with x to the 3rd power. It's more commonly called x cubed. And you've seen this kind of notation before when you gave the expanded form of a whole number for powers of 10 in previous years. And that was called exponential notation.